Download this code from codegive.com, link in the description below. OK, let's dive into Debug Your Thinking as presented by Laila Bougria at NDC Sydney 2024. While I don't have the exact video or presentation transcript, I can reconstruct the likely core concepts and augment them with code examples to illustrate the ideas. The overall goal is to help you identify common thinking errors, biases, and cognitive distortions that can impact your decision-making, problem-solving, and ultimately, your code quality. Central idea: thinking as a program and debugging techniques. The core analogy is this: treat your thought process like a program you are writing. Just like code, your thinking can have bugs, errors, and inefficiencies. Debugging, in this context, means identifying, understanding, and correcting these cognitive flaws. Key concepts and debugging strategies. Here's a breakdown of the common concepts and debugging strategies that Laila likely covered, along with code examples to help relate them to software development. 1. Recognizing cognitive biases and heuristics ****. Definition **** Cognitive biases are systematic patterns of deviation from norm or rationality in judgment. Heuristics are mental shortcuts that allow people to solve problems and make judgments quickly and efficiently, but they can lead to errors. Bugs in your thinking ***. These biases can lead to flawed requirements gathering, design decisions, code implementations, and testing strategies. Debugging strategy, awareness and checklists ***. The first step is knowing about common biases. Then, use checklists and structured questioning to identify if you're falling prey to them. Common biases, with code-related examples. Confirmation bias ***. The tendency to search for, interpret, favor, and recall information that confirms or supports one's prior beliefs or values. Code example ***. Imagine you believe that using a specific framework X, is always the best approach for a particular task. Debugging ***. Actively seek out evidence against your belief. Try comparing framework X to other frameworks in a fair and comprehensive manner. Use benchmarks. Run a range of test cases. Anchoring bias over-reliance on the first piece of information received, the anchor, when making decisions. Code example estimating the time to complete a feature based solely on a very early, vague estimate, even when you gain more information that suggests it's wildly inaccurate. Debugging actively challenge the initial anchor. Get multiple estimates from different perspectives. Break down the task into smaller, more manageable pieces and estimate those individually. Use techniques like planning poker. Availability heuristic overestimating the likelihood of events that are easily recalled, example recent events, vivid events. Code example choosing a particular design pattern because you recently used it on a successful project, even though it may not be the best fit for the current problem. Debugging actively seek out data and information that is not easily available. Perform research, consult experts, and consider alternative solutions. Groupthink the desire for harmony or conformity in the group results in an irrational or dysfunctional decision-making outcome. Code example agreeing with a senior developer's design choice without fully understanding or challenging it, even if you have doubts. Debugging encourage dissenting opinions. Designate someone as a devil's advocate. Use anonymous feedback mechanisms. Ensure everyone feels safe to express their views. Sunk cost fallacy continuing to invest in a failing project or idea because of the resources already invested. Code example sticking with a poorly designed legacy system because a significant amount of time and effort has already been spent on it, even though rewriting it would be more efficient in the long run. Debugging * focus on future costs and benefits, ignoring past investments. Evaluate the project's current viability objectively. Consider the opportunity cost of continuing the project. How to apply this in code code reviews use structured code review checklists that explicitly address potential bias. Testing design test cases specifically to challenge assumptions and biases. Think about edge cases that you wouldn't normally consider. Pair programming having another person review your code and thinking can help identify biases you might have missed. Documentation document the rationale behind decisions to expose assumptions and biases. 2. Recognizing logical fallacies definition flaws in reasoning that render an argument invalid. Bugs in your thinking logical fallacies can lead to incorrect conclusions and poor solutions. Debugging strategy, learn common fallacies and challenge assumptions familiarize yourself with common logical fallacies and practice identifying them in discussions and arguments. Be prepared to challenge your own assumptions. Examples, with code-related examples. Strawman misrepresenting someone's argument to make it easier to attack. Code example saying that someone who argues for using a functional programming style wants to eliminate all variables from the code base. Ad hominem attacking the person making the argument rather than the argument itself. Code example dismissing a code review comment simply because it came from a junior developer. False dilemma, false dichotomy presenting only two options when more exist. Code example arguing that a project can either be completed quickly with technical debt or slowly with perfect design. Appeal to authority asserting that something is true simply because an authority figure said so. Code example we must use this microservice architecture because our CTO said it's the best approach, even though our team doesn't have the experience or infrastructure to support it. 3. Metacognition, thinking about your thinking. Definition awareness and understanding of one's own thought processes. Thinking about thinking. Bugs in your thinking lack of metacognition can lead to a lack of self-awareness, making it difficult to identify and correct cognitive biases and logical fallacies. Debugging strategy, reflection and journaling regularly reflect on your thought processes. Keep a journal to record your decisions, the reasoning behind them, and the outcomes. Analyze your past mistakes. Code example after a particularly challenging debugging session, write down the problem you were trying to solve. Your initial assumptions. The steps you took to debug. The mistakes you made. What you learned. How you could have approached the problem more effectively. 4. Structured problem-solving techniques definition using systematic approaches to break down complex problems into smaller, more manageable parts. Bugs in your thinking failing to use structured problem-solving can lead to unfocused efforts, incorrect solutions, and wasted time. Debugging strategy, adopt a framework use techniques like the 5 whys repeatedly asking why to drill down to the root cause of a problem. Root cause analysis systematically identifying the causes of a problem. PDCA, plan do check act a continuous improvement cycle. Design thinking empathize, define, ideate, prototype, test. Code example, the 5 whys. 5. Embrace failure and learn from mistakes. Definition view mistakes and failures as opportunities for learning and growth, not as reasons for shame or discouragement. Bugs in your thinking. A fear of failure can lead to risk aversion, lack of innovation, and an unwillingness to admit mistakes. Debugging strategy, post-mortem analysis and blameless culture. After incidents, conduct thorough post-mortem analyses to identify the root causes of the failures. Create a blameless culture where team members feel safe to admit mistakes and share lessons learned. Code example. 6. Diversify your information sources and perspectives. Definition. Actively seek out information and opinions from a variety of sources, especially those that challenge your existing beliefs. Bugs in your thinking. Relying on a limited set of information sources can lead to confirmation bias, groupthink, and a narrow understanding of complex issues. Debugging strategy, read widely and engage in constructive dialogue. Follow diverse voices on social media, attend conferences with varied perspectives, and engage in constructive dialogue with people who hold different viewpoints. Code example. Applying it to your coding practice. Requirements analysis. Actively question assumptions. Are you truly understanding the user's needs? Challenge the product owner to explain the why behind the feature request. Design. Explore multiple design options. Don't just go with the first thing that comes to mind. Consider different architectural patterns and data structures. Coding. Write clean, well-documented code that is easy to understand and test. Don't assume that you will remember why you made a particular decision 6 months from now. Testing. Design comprehensive test suites that cover a wide range of scenarios, including edge cases and error conditions. Debugging. When debugging, don't just blindly try different things. Formulate a hypothesis, test it, and analyze the results. Code reviews. Use code reviews as an opportunity to identify potential biases and logical fallacies in your code. In summary, debug your thinking is about applying the principles of debugging, familiar to every programmer, to your own cognitive processes. By understanding common biases, logical fallacies, and metacognitive concepts, you can improve your decision-making, problem-solving, and coding skills. The code examples provide a way to ground these abstract ideas in your everyday work. Regularly reflect on your thinking, challenge your assumptions, and be open to learning from your mistakes. This leads to better code, better products, and a more effective you. Remember, continuous improvement applies to your thinking just as much as it applies to your code.